Earth, the third planet from the Sun, is a living, ever-changing satellite on which volcanoes erupt with incredible violence. Molten lava oozes out of undersea faults. Mountains fold and buckle into awesome formations. Whole new islands are created, rising almost overnight from the depths of the sea. And mountains explode in enormous clouds of ash. These dynamic and constant changes of Earth's surface occur because our planet's crust consists almost entirely of cool, solid rock, which is divided into plates. Hot fluid rock cycling inside the Earth sets these plates in motion, their collisions and separations causing continuous geological change. For instance, when a heavier oceanic plate slides under a lighter continental plate, it melts in the hot interior. Molten rock rises upward, producing new mountain ranges and volcanic explosions. When two continental plates collide, sky-high mountains result. When two plates slide by each other, a fault many hundreds of miles long is formed, causing earthquakes. And when two plates separate, the hot, fluid rock flows out and solidifies into new crust. In this way, seafloor ridges are developed and continents are set in motion. These violent acts of nature, caused by the collision, separation, or sliding of the Earth's plates, have been occurring for hundreds of millions of years and are responsible for the ever-changing face of our planet. The study of these dynamic processes is called plate tectonics. 500 million years ago, this is what the Earth looked like, and how the continents were shaped. Their positions on Earth were very different. North America and Europe were at the equator and had tropical seas, which supported abundant marine life. As Africa and South America drifted across the South Pole, extensive ice and snow cover developed. About 400 million years ago, Europe and North America drifted together and became one landmass, and life expanded onto land. About 300 million years ago, other continental plates collided to form one enormous supercontinent called Pangea. During this period, many animals and plants were widely distributed across the combined landmass. Plants covered the land, providing a home for increasing numbers of reptiles. About 200 million years ago, Pangea began to break up, and the Atlantic Ocean was created. Plants and animals became isolated and increasingly diverse. North America had a mild climate at this time, and reptiles, including dinosaurs, dominated the land. 100 million years ago, North and South America moved still farther away from Europe and Africa. Dinosaurs became extinct during this period, and many other animals, for reasons as yet unclear, also disappeared. Mammals began to dominate the land. 40 million years ago, Australia began its isolation as it separated from Antarctica. India collided with Asia and uplifted the Himalayas. Today, each continental plate, isolated by oceans over millions of years of drift, has its own unique plant and animal life. The continents are still drifting, but at a rate of 1 to 3 inches per year, it is far too slow for us to notice. However, at that rate, every year for the next 50 million years, this is how our planet will look. The Atlantic Ocean will continue to widen, and the Pacific Ocean will grow narrower. Australia will collide with Indonesia, and Southern California will drift away completely from the North American continent, and move into the Gulf of Alaska. The effect this will have on Earth's climate, its vegetation, and its living creatures will undoubtedly be dramatic. Plate tectonics has been one of the major contributing factors to physical and evolutionary change on our planet, and is an important new science that will help us to better understand the ever-changing planet on which we live.